Did you know that this snake and ladder game was invented in India to teach kids some moral lesson? So let's try to implement it here. This is a Leetcode premium problem, but it's not that hard. Let's try to implement it here. Okay, so you are given an n cross n integer matrix board where the cells are labeled from 1 to n square. These cell blocks are labeled from 1 to this n square. Here n is 6, so we have 6 cross 6 board, and cell blocks are starting from 1 till 6 in the first row, n minus 1 row, then in n minus 2 row it's starting from it's going from right side to left side. So this is the zigzag style it is following, and at each step we are rolling a dice. We are rolling a die of which has 6 sides, right? If we are at 1, we can move to 2, 3, 4, 5, 6 and 7. But there is a catch, like if we can have a snake or ladder at any point from this next cell blocks, right? So let's say here at 2 we have a ladder and we are reaching 15. So how the matrix is represented here is -1 and some other values. If it is -1 means there is no ladder or snakes, and if it is some other value, like here you see 35 and you see here 15, right? So that means there is this ladder or snakes that is going to that particular cell block. Now we have to find out, return the least number of die rows required to reach the square in square. Okay, one more thing we have here is if the destination to a snake or ladder is the start of another snake or ladder, we do not follow the subsequent snake or ladder. Like if you see there is, if from 2 we are reaching 15, right? But at 15 if we can have one more snake or ladder, so we'll not follow that, right? So we'll just consider one level of this snake or ladder. So now here we have this board and its representation. So boards are having real values, and here in the representation matrix, board matrix, we have -1 where we don't have any snakes or ladders. But if we have any snakes or ladder, then that snake's ladder value. Like here at 2 we have a ladder that reaches 15. So at place of 2 we have 15. Right. Similarly, at 17 we have a snake that reaches 13. So in the place of 17 we have value 13. Now my question is here, our question is we have to start at 1 and we have to reach this n square. Here the board size is 6 cross 6, so we have to reach 36. And what is the shortest distance from here to here? You see, if we are at 1, we are rolling a die and that has 6 sides, so that will have values from 1 to 6, right? So from 1 we can reach 2, 3, 4, 5, 6, 7, right? These 4 values we can reach from 1. But if we are going to 2, then we will reach 15. So in place of 2 we'll get 15. So all these values are cell blocks that we can reach from 1 with just one distance. Then if we are starting from 3, we'll reach 4, 5, 6, 7, 8, 9, right? From 3 we'll reach 4, 5, 6, 7, 8, 9. Now you see here from 1 we already reached 4 with distance 1. From 3 also we are reaching 4, but that is total distance is 2. Right? So we'll not consider any cell block that is already visited, and this is a shortest path problem. So in most of the cases, shortest path means we have to use a BFS graph based traversal approach, right? And basically how in the visited set we'll keep track of the already visited sets with that distance, and will not process any further cells if it is already visited. So let's say we will take one queue. For VFS we need a queue, and first we will add 1 with distance 0. And from 1 we can reach 2, 3, 4, 5, 6, 7, and in place of 2 I have written 15 because we can reach 15, and all these cell blocks we can reach with distance 1. Then we'll pop each of these values and we'll add its next values. Like if we are popping 15, we'll add 16, 17, 18, 19, 20, 21. And if we are popping 3, then we'll add the 4, 5, 6, 7, 8, 9. But we'll not insert this 4, 5, 6, 7, 8, 9 again because these are already inserted in this queue. And we'll keep track of a visited set to do that. And ultimately we have to return the distance of this n square block. So the problem, this is a very simple problem, but the problem here is how do we map these levels with the row and column, right? So to know whether this particular cell block has any ladder or row, so we have to go to this board and see if the value is -1 or not. If we are rolling a die and we are just have these levels, we are getting 1, then we do know 2, 3, 4, 5, 6, 7. But we can have a mapping so that these labels can be mapped to row and column. Like this cell block will be mapped to some row column. Row. So I will traverse for row in range n-1 till 0 in this way order. And we are taking one, so this should be a dictionary where I will keep this mapping. And blocks are starting from 1, so this is 1, and then we'll keep incrementing this block. For row in range from n-1 to 0, we have to process each columns. Now columns are going from 0 to n-1 for this row, but in this row it is going from n-1 to 0, right? It's increasing in this order, 7, 8, 9, 10, 11, 12. Again it is improving in this order, 13, 14, 15, 17, 18, 19. So I have taken one columns, that is a list in the range n, means this is basically a list from 0 to n-1. So for each row I am taking for column in columns. So the first one it will take for 0 to n-1 in this range. I am just updating the blocks dictionary. Blocks of this current block will be this row and column, and we are incrementing the block. And after processing each row, I am just reversing these columns. For the next row, it will be from the n-1 to 0. And after this processing, we'll have this mapping where we'll have 1 map to n-1, 0, 2 map to n-1, 1, let's say 12 map to n-2, this will be 0, right? So this way we need this mapping. Okay, first we'll take one n variable, that is the length of this board, and we need the blocks. This is a dictionary. This will keep track of the block to row column mapping, right? And block will start from 1. Now I have to traverse through this board and get the row column. So for row in range, so blocks are starting from this n-1th row and going here. So rows will start from n-1 till 0. And how the columns are going, columns are starting from 0 to 1, 0 to n-1 for the first row, for the n-1th row. For the next row, it is from n-1 to 0. So it is alternating in reverse order. So let's take one columns that is in range n, means 0 to n-1, but I will reverse it for each row. For column in columns, we'll just process blocks of block is this row and column, and we'll increment the block, and for each row I am just reversing the columns. So next time it will be from n-1 to 0. So that's it. My this mapping is processed. Next we have to do the DFS with a queue. So I will start the BFS with block 1, and block 1 will have distance 0. Next also I need a visited set. Visited set will have 1 first. Next we'll run a for while loop till we have any element in this queue. We'll pop element from the left. We'll get the block and the distance, right? Q dot pop Q dot pop left. Now we'll process the next block of this block, right? So for if it is current block is 1, next blocks will be 2, 3, 4, 5, 6, 7, but 2 will not be next block because it has a ladder. It will go to 15. So we'll see how we'll process the snake or ladders, but next block will be in range block +1 till block +6, but it will be minimum of block +6 and n square, right? Because if you see for this log, we don't have block plus till block +6, so it will be minimum of block +6 and n square +1, because we want to process till that block. Now what will be the row and column? We need the row and column because in this board we can have either -1 or some other value for snake and ladders. So we want to get the row and column for that block, and then we'll see in the board what value is present. So row and column we'll get from this blocks we processed, blocks of this next block, right? And what will be the destination? Destination will be next block if in board of this row, and in row and column position of this board we have -1, right? Otherwise it will be that other snake ladder value. So if it will be board row column, if board row column not equals to -1, else next block. Now we have to process this next block, destination. If destination not in visited, then we'll add it in visited, and also we'll add it in this queue. What will add in queue? We'll add a tuple with destination and the distance of the destination. And what will be the distance of destination? It will be the distance of this current block +1, right? So distance +1. So that's it. And also when I'm popping a block that is n square, then we can just return this distance, because we want the distance, shortest distance of this n square block. So that's it. If this while loop doesn't return anything, that means there is no answer, means we cannot reach this n square block, right? So in that case we can return -1. So let's run this. Yes, it works. Let's submit this. Wow, this is pretty efficient. This is the code. Let's see the complexity. It's n square. Let's see. Okay. Why it is n square? Because BFS complexity, time complexity is always order of V plus E. And here the number of nodes or cell blocks are n square, right? From 1 to n square we are processing. For each blocks, let's say from 1, I can reach from 2 to 7, 6 blocks. So for each blocks we have 6 blocks, means the total number of edges is 6n square. Order of 6n square edges will be processing. So overall time complexity here will be order of n square.